Now we're going to look at partial fraction decomposition when we have repeated linear factors. So this denominator is factored and we have linear factors, but this one is squared. So if we were looking for the partial fractions, here I have x squared plus 2 over x minus 1 and x plus 2 squared, we would have one fraction with the denominator x minus 1 plus we would have the next fraction with the denominator x plus 2, and sort of students' gut feeling here is there should be another one with x plus 2. But that's not going to work, because if I gave you these and said what's the common denominator, it would be x minus 1 times x plus 2. And we could actually combine these two under one fraction, and the x plus 2 would only appear once. So that's not going to do it. What has to happen is this other fraction has to have an x plus 2 squared. That way, when we get a common denominator, when we combine these, we would have an x minus 1 and we would have an x plus 2 squared, and this is absorbed in that. So it could have been any of these fractions added together would have this common denominator. So in general, if you were looking and the denominator, say, had an x minus 1 and an x plus 2 to the fifth, when you are looking at the partial fraction possibilities over here, you'd have to have one that had an x minus 1, you'd have one that has an x plus 2 to the fifth, another one that had an x plus 2 to the fourth, another one that had an x plus 2 to the third, another one that had an x plus 2 squared, and then a last one that had x plus 2, because when you get the common denominator of all of these, it would look like this. So you'd need to consider all of those possibilities. So repeated factors, we need a fraction for that factor to that power, and then we need one for each lower power. Now let's continue with the one we have. So if we clear the fractions, if we multiply everything by x minus 1 times x plus 2 quantity squared, that would disappear here. The x minus 1s would go here, and we'd have left an x plus 2 squared. One of the x plus 2's would go here, and we'd have left an x minus 1 and an x plus 2. And the x plus 2 squared would go here, and so we would have left x minus 1. So let's write down what we have left. We have x squared plus 2 equal a times x plus 2 squared plus b times x minus 1 times x plus 2 plus c times x minus 1. So now let's conveniently choose an x. We're going to let x equal 1. 1 squared is 1 plus 2 is 3 equal 1 plus 2 is 3 squared is 9a. Putting a 1 here will zero this out. Putting a 1 here will zero this out. So a equals 1/3. Let's let x equal negative 2. Negative 2 squared is 4 plus 2 is 6 equal negative 2 will zero this out. Negative 2 will zero this out. Negative 2 minus 1 is negative 3c. So it looks like c equals negative 2. That's great, but how are we going to find b? What we're going to do is we're going to choose another x, and it's not one that's going to zero anything out, but we've already got the a and the c, so we will substitute those in with the x that we choose, and then we're going to be able to find b. So maybe I will just let x equal 0. I just picked 0 because zeros usually makes things a little easier. We'll see. So I put it 0 here, plus 2 equals 2. I put in the 1/3 for the a, putting a 0 here. 2 squared is 4, so this will be times 4, plus putting 0 here and 0 here, I'll have negative 1 plus 2, so that's going to be negative 2. So this will be negative 2b. And then putting a 0 here, it looks like we will have minus, and then putting in negative 2, that'll make that a plus 2 for the c. Now we just need to solve this for b. So these 2's will cancel, and if we move this over, we will have 2b equals 4/3. So b is going to equal 2/3. So here's our b, here's our c, and here is our a. So this we can split up into 1/3 over x minus 1, and then b was 2/3, so plus 2/3 over x plus 2, and then c was -2, so minus 2 over x plus 2 squared dx. So we did our partial fraction decomposition. We have this integral now into 3 separate fractions, and now we're ready to do the integration. In order to do that, I'm going to erase our partial fraction stuff so we can see where we are. So let's see about working this integral. So this is going to be 1/3 natural log of x minus 1, absolute value there, plus 2/3 natural log of x plus 2. Remember, when we do these, the chain rule applies. I've considered here, and the derivatives of those are 1, so we're good. Now, how am I going to work this one? Well, I'm going to think of it as x plus 2 to the -2. So as I look at this, because from the chain rule this derivative is 1, I'm not even going to bother with u substitution. So if this was 1 higher power, this is a -1. If that would have come out in front, that's where the negative. So this is going to be a plus. So we're going to have 2 over x plus 2, and then plus a constant.